Suppose we want to determine the roots of this general quadratic equation of ax squared plus bx plus c equals 0. We can use factoring to determine the roots. However, factoring can only determine rational roots. So when we have irrational roots or imaginary roots, factoring can't help us. But completing the square, the method completing the square, can find all all kinds of roots. So let's try to use completing the square. So the first step is to divide the numerical coefficient of x squared, a. Divide a from all of the terms. So divide by a, okay, ax squared over a, bx over a, c over a. We can also divide 0 by a. Yeah, let's do that. So this left side will become x squared plus b over ax, b over a times x plus c over a equals, and 0 over a is just 0. Okay. Then we can add negative c over a both sides, so we can get x squared plus b over a times x, which is equal to negative c over a. And now, using completing the square, so let's just copy this first. X squared plus b over a x is equal to, let's put it here, negative c over a. So by using completing the square, we can determine, we can add something here. So we can add b squared over 4a squared. So why can we do that? We add b over 2a quantity squared. So b squared over 4a squared. And whatever the number or the value that we add here on the left side, we must also add it on the right side. So b squared over 4a squared. And this left-hand equation will become x plus b over 2a quantity squared. And this right-hand equation here, we want them to be in one fraction. However, they have different denominators, so we can get the LCD. And their LCD is 4a squared, and so there's no need to manipulate or multiply anything here in b squared over 4a squared. But here in negative c over a, we can multiply this by 4a, both the numerator and denominator, so that the denominator will be 4a squared. So let's do that. So we will get b squared over 4a squared minus 4ac over 4a squared. Okay, let's just copy it here. X plus b over 2a entity squared is equal to, and now we can combine them because they have the same denominator. They're this similar fraction, b squared minus 4ac all over 4a squared. And now we can take the square root. So that's what we do in completing the square. Take the square root for both sides. So square root of x plus b over 2a quantity squared plus minus is equal to plus minus square root of b squared minus 4ac over 4a squared. This left-hand side will become x plus b over 2a, and the right-hand side will become plus minus square root of b squared minus 4ac over square root of 4 and square root of a squared. This will become 2a. Now we want x is equal to something. So we want, um, so we add negative b over 2a on both sides. So we get x is equal to negative b, and since they are the same, they also have the same denominator, we will just combine them into one fraction. So b, negative b plus minus b squared minus 4ac all over 2a. And this is what we call the quadratic formula. Okay. So let's try to use this formula in solving for a root, for the roots of a quadratic equation. Okay, and if you can't understand my handwriting, okay, here is the derivation of the quadratic formula from the standard form of a quadratic equation. Yeah, you can get the quadratic formula by completing the square. And now let's try to solve 2x squared plus 3x minus 2 using this formula. So it's just easy when it's already arranged like ax squared plus bx plus c equals 0. So we can first determine a, b, and c. So a, let's see, and let's color code it. So this is a, which is 2, b, which is the coefficient of x, so b is equal to 3, and c is equal to -2. So what we can do, we can substitute these values here. So we will get x is equal to, okay, let's just put it like that, -b, that is -3, -3 plus minus, uh, plus minus square root of b squared, which is 9, 3 squared, or let's compute later, or let's simplify later, minus 4 AC, 4 times 2, um, yeah, 4 times 2. I haven't used other color, but here is the value for A. Let's have a different color so that we can see it. So our A must, maybe it's green, right? So A is equal to 2. So 2 times C, which is -2, times C, which is -2. Right. And this, everything, uh, uh, and this, all of this is have the denominator of 2 times 2. And if we want to compute this value, we just simplify it. Okay, so x is equal to -3 plus minus square root of 3 squared. That means 3 times 3, so that is 9. Now, in multiplying numbers, values, you can just first multiply the values and forget about the sign first. So 4 times 2 times 2, that is 16. And if we want to determine the sign or the operation, if it is addition or subtraction, we can imagine negative times positive times negative, and that is positive. So this is addition. And everything, and the denominator must be 2 times 2, which is 4. Okay, if we further simplify, x is equal to -3 plus minus square root of 25 over 4, which will get x is equal to -3 plus minus square root of 25 is 5 over 4. And so we can determine the roots by this. So plus minus means we can add 5 or we can subtract 5. So if we add 5, -3 plus 5 equals all over 4. That is equivalent to 2 over 4, which is equivalent to 1/2. And this is the one root of the equation. We can also subtract 5. So we put, or x is equal to -3 minus 5 over 4. So that means -8 over 4, or which is equivalent to -2. So this is another root for our equation. So 1/2 and -2 are the roots for this quadratic equation, 2x squared plus 3x minus 2 equals 0. That's it. how we derive and use the quadratic formula. More of this in the next video.